Next topic is feature scaling. So what is feature scaling? Feature scaling also we do it as part of the feature engineering phase. In the life cycle. So as part of the data pre-processing, we have seen how to perform feature encoding. Next one is feature scaling. So feature scaling, we do it as part of feature engineering or data pre-processing. Now the question is, what is feature scaling? It is one of the most important data pre-processing step in machine learning. Which one? The feature scaling. It is the process of normalizing the range of features in a data set. So what do you mean by this one, the normalizing the range of features? What does it say? For example, I have, if you see the below table, we have name, weight, and price. So weight and price, if you look at this here, the weight values are more, and price has just only one digit, whereas here the weight is more. Another example is age and salary. So age, it can go maximum, right? It can go up to maximum 3 digits only. In the case of age, right? 100 years. No one live 1,000 years, right? So 100, so maximum 100, 106, that's all, right? 100, 3 digits. Whereas salary or income, let's say you have income column. Okay, income can be anything. If you're a businessman, like Sundar Pichai, right? A top corporate guy. So you might be getting in crores together. Right, so it can be a 4 digit, 5 digit, 10 digit income. Income can be 10 digits. Some people have passive income. Okay, passive income also, right? The passive income is more than their monthly salary in primary income. Okay, so in that case, these income column will have a different unit of measure, whereas age column will have a different unit of measure. You need to convert all these kind of features into a common scale. Why should I convert all these features into common scale? Because each column or each feature has different unit of measure. Okay, let it be there. So what is going to happen if I have it like this while training the model? When you train the model will give more weightage to the column, right? So in this case, right, in this case, the weight cannot have a meaningful comparison with the price. So in this case, the algorithm will make an assumption, right? Since weight, when comparing the weight and price, right, it'll think that weight is more important than price because the magnitude of the variable income or weight is more than price. Hence, the model will think the weight column is more important than price. Okay, so in order to address this bias, so what we do is we will convert all these type of variables with different unit of measure into common scale. So, okay, if I do it, what other advantage I'm going to get? From the machine learning point of view, it will not, it will not have a bias over the column which has higher values in it, fine. And also the other advantage, the algorithms can converge faster when features are relatively smaller or closer to the normal distribution. Got it? This is one of the important or essential step as part of the machine learning algorithm that calculate distances between the data. Another advantage of this one is the algorithm can converge faster when features are relatively smaller. Okay, in the case of gradient descent, when you do the feature scaling, the model will converge much faster with feature scaling, and also algorithms like linear logistic regression, principal component, linear discriminant analysis. These kind of algorithms, when you do the feature scaling, it'll converge much faster. Okay, so what do you mean by converge much faster? Take for example, in the case of gradient descent, if you do the feature scaling, the key advantage of using gradient descent algorithm is to minimize the error. Okay, so that is the one. So when you iteratively, the keep changing the values for the parameters, and then when you keep iterating it and keep changing it, right, keep finding the gradient, and when you keep changing the values for the parameters iteratively, what happens is it can converge faster, right? So because of the feature scaling, because all the values, all the variables are scaled in a common thing. So when you do the feature scaling, the values will be bounded between 0 and 1, almost all the variables. Okay. So there are different types of feature scaling. The one is min-max scalar and standard scalar and robust scalar, and the rest of them, or like the max app scalar and so on. Okay, these are the types of feature scaling are available. First of all, let us understand what is normalization. Min-max scalar. Okay, min-max scalar is also called as min-max scalar is used to do the normalization. So this is a scaling technique. In this case, the columns are shifted, and the values will get transformed between the range of 0 and 1. So this is the formula. Xi, right? For each value, you need to subtract the minimum value. For example, you have 1, 2, 3, 4. What is the minimum value? 1. So you need to subtract from each and every value, and divided by the maximum is 4. 4 minus minimum is 1, right? So you're right, for each and every value you need to do it in order to transform, convert them, between the range of 0 and 1, so that all the variables, all the independent variables in your model will get converted into common scale called normalization. So in sklearn package, there is a transformer called min-max scalar that is available to do the normalization. And next one is standardization. Okay, so using standardization, we can rescale the data to have a mean as 0 and variance as 1. Okay, this is the formula for standardization. Xi minus mean of x standard deviation. So you need to subtract the mean from each and every value, and you need to divide it by standard deviation. So this is the notation we use it. Xi minus mu divided by sigma, the denominator sigma, and z, we use z. Okay, this is also called as z score. So we use standardization technique, majority of the time to perform the standardization. So the sklearn provides the transformer standard scalar. Min-max scalar is for normalization, and the standard scalar is for this one, the standardization. And apart from this, we have something called robust scalar. So this is the one converts your column by subtracting the median and then dividing it by the interquartile range, 70% minus 25%. This is the formula. Okay. So the robust scalar, it does not scale the data into a predetermined interval like min-max scalar. Okay. It does not meet the strict definition of scale 1, right? So that is the one thing. So in this case of robust scalar, right? So now the question is, when can I use robust scalar? If you wanted to reduce the effect of outliers, right, relative to min-max scalar. So in that kind of, if you think you have some outliers in your columns, right, in that kind of situation, to reduce the effect of outliers, because outliers, there are some outliers, it can, influence your model, probably it can influence the errors, right, the outliers. So you can use, in that case, you can use robust scalar. Okay, so in that kind of situation, you can use a robust scalar. This is the formula for robust scalar. Now the question is, the billion-dollar question is, when can I use which kind of scalar? So you can use min-max scalar if you are transferring a feature. It's not distorting. Okay, which means you don't have any outliers, then you can go for min-max scalar. If you have an outliers, you can go for robust scalar to reduce the effect of the influence of outliers. And standard scalar, you can use it for relatively normal distribution. If you have a column which is normally distributed, in that kind of situation, you can go for standard scalar. All right, so now we will get into Python, and we will take a look at how we can perform each of these things. Okay, what I do is I just go to the multiple linear. This is the one I shared with you all. Look here, I just go and click on this one, and the next one is I just import this one more time. Housing data, I'm using the same data here, and I just drop this thing, and here I just simply use this one. So in this case, I just used only these two independent features. The next one is I'm going to do the train and test split. And okay. So here I'm going to do the training and test split. Okay. And the next step is I'm going to use the standard scalar. Okay. From scalar pre-processing. So look here, the pre-processing is very good. The another advantage is pre-processing, right? You can do feature scaling and you can do one-hot encoding. Okay, you don't have to, in that case, right, you don't have to import multiple different packages. If you import more packages, it will consume more memory, right? So you can use scalar and pre-processing to do the feature scaling. As part of this, you have standard scalar class is available. Okay, in this case, we are going to apply the function onto the data set, right? So so we are going to apply the function fit transform on this extrain data set. Okay, and then training data set also I'm going to do the same thing. Okay, so my data will get scaled now. If I look here, if I do this, and if I do something like x underscore train dot head function. Okay, here yeah, I cannot use train this one. Let me do next train. See, almost all the values are right. Somewhere between minus, we don't see anything greater than 2 or something. Right? So almost all the values are got converted between the negative value and the less than 2, right? So not less than 1. So this is minus negative values 0 and 1, right? So it is doing it everything, but somewhere we can see that 1.171, 1.52 standard scalar, whereas when you use the min max scalar, one second, here the extrain, if I select it here, okay, so if I do min max scalar, what will happen? So already I did I used the z-score, okay, the standard scalar. Already my training and test data got converted. On top of this, if I use normalizer, it is not good. So what I do is I'll have to re-import the data to understand for demonstration purpose. Okay, in real time, don't use multiple thing. Okay, and here now what I do is, okay, I need to go here and split the data again. I need to train test split from the beginning. And then what I do is here min max scalar. And if I use extrain, and you can see almost, yeah, in the case of normalizer, it is converting the values between 0 to 1, right? All the columns. Because in this extrain, we have two independent variables. Both the independent variables are numeric. Okay, so that is the prerequisite. Okay, all the variables should be numeric when you use min max scalar or standard scalar. It is meeting that requirement, and if you see the values, it got transformed between 0 and 1. Fine. And the next one is the robust scalar. Same thing. Okay, so again you need to go up and re-import the data. Okay, so here size and UDS, but in these two variables I don't have any outliers. Anyhow, let it be there. So robust scalar is helpful in the case of outliers. If you have an outliers in a data set, right, you can go for this one, robust scalar. Pre-processing dot robust scalar. Scalar equal to 1 second. Scalar dot pre-processing. Okay, let me do one thing. Okay, here I suppose to use. I have imported the class robust Scholar, and I have created an object called Scalar. Okay, now what I do is using this object, I'm going to apply the method fit transform, which is available as part of robust Scalar, to transform the xtrain, and this is sorry, this is xtest. So in the case of outlier, you can use this. And now the question is, sir, I have some columns, I have outliers, some columns. I don't have this one outlier, right? So I have a mix of these two things. So usually what we do is we address the outliers using something called capping technique. We'll explain it later. Okay. We do capping for the outliers. Once you do the capping, then you don't need robust scalar and all. Simply you can use the standard scalar. So most of the situation we use standard scalar, and in some cases, right, we use interchangeably we use either min max scalar or standard scalar. But the Z score, which is nothing but a standard, this is the one is used in most of the projects. Okay, so in that case, right, you can, the data is not if you don't have any outliers, all the features, right? Or even if you're an outlier, let's say you address the outliers by doing capping, then you can simply go for min max color, or you can go for standard color. There are two different options. Okay, both of them are good. Okay, you can use any one of them. But z-score is more reliable. If you see, if you check with people, right, in the industry, they say the z-score is the one is used by widely by many of the data scientists. So we can go ahead with standard scalar in this case. So now you understood as part of data pre-processing, apart from the common data cleaning, like removing the duplicate records, and you know very well how to perform data imputation. We have seen the data imputation part in the past, right? So fill any function, using fill any and using is any function or is null function, we can find out any missing values are there in the columns, and using fill any we can perform conditional data imputation. Now we can perform conditional the mean imputation also, we have seen it, right? So once you address the missing data issues by performing the data imputation, and once you address the outliers, and you are good to go with the feature scaling. Feature scaling is very much important, as I said, right? Using once you convert your numerical variables into all your independent variable, which means the numerical variable into a common scale, the algorithm, right, will converge much faster. Fine. So now with this, we have understood what is feature scaling is all about, and we have explored the different classes or the packages that are available in order to perform the feature scaling.